In the multithreaded DAG model, you represent a parallel computation by a directed acyclic graph, or a DAG, like this one. Each vertex is an operation, like a plus or an addition or a function call or a branch. The directed edges show you how operations depend on one another, where the sinks depend on the sources. So this would be a sink, and this would be a source, and this would say that C depends on the output or result of B. Now, to keep things simple, I'll always ask you to assume that there's exactly one starting vertex and one exit vertex. So in this example, here's the start, and here's the exit. And of course, if you have a DAG and there are no such vertices, these start and exit ones, it's pretty easy to add them. Now, suppose you have a PRAM machine and you want to use it to run the computation. You start by trying to find any operations that are ready to go. That is, all of their input dependencies are satisfied. So in this example, take a look at the starting vertex. That one's ready to go. Since it's ready to go, meaning it has no dependencies, we can assign it to any processor that's free and go ahead and start executing. So here I've assigned the starting vertex S to processor 3, and processor 3 will start executing it. Now, as soon as a processor finishes its operation, it enables any of its successors to begin. So in this example, A and B only depend on S, so as soon as S is finished, A and B can start. So now A and B are ready to go. So we can look for any free processors and assign A and B to them. So for example, it looks like processor 1 and processor 3 are free, so let's assign A and B to them. Now when processor 1 and processor 3 finish their units of work, then that will enable other successors, in this case, vertices C and D. And this process will repeat until we finish. Now, at every step of the computation, this problem of how to take free units of work and assign them to processors is called the scheduling problem. Scheduling is a huge topic, and you will hear more about it soon enough. Given a DAG and a PRAM, here's a question. How long will it take to run the DAG? To answer this question, you need a cost model. For now, I'm going to use a cost model that makes 3 assumptions. The first assumption is that all processors run at the same speed. The second assumption is that each operation takes 1 unit of time. And the last assumption is that these edges don't have any costs associated with them. So let's start with these assumptions and let's apply them to some sample DAGs.